So talking about graphing quadratic functions again, looking at number 1, what's different about number 1? There's like nothing there, right? But we still have that most important part, that x squared. Okay, because that's what tell us what our graph's going to look like. What is our graph going to look like? Remember the word?
Parabola.
Close. Parabola. Yep, parabola. Okay. What was our most important point to find? The vertex, right? How did we find the vertex? You remember?
X equals -b divided by 2.
Yep, negative b over 2a. I just heard a bunch of light bulbs go off. Okay. But what is our b? We don't have one, so if we don't have one, we use 0. Okay? And then 2, what's our a? Times 1. So we have 0 divided by 2, which is just 0, right? So that's our x value. How do we find the y value for that?
You gotta put it in the equation.
We just plug it in, right? But if you plug it in, what is our normal y value? It's that c, right? We don't have a c. So if I plug 0 in, what comes out? 0. Yep. So our vertex is 0, 0. So at our origin, that is our vertex. And then how do we find our 2 other points?
You go on each side.
Yep, you pick one on each side. Yesterday we talked about finding the y-intercept, but we already have the y-intercept. It's that origin. Okay? So we have to pick 2 points. So what points can I pick?
-1.
-1 and
1.
1. Yep. So if I plug in -1, what's -1 squared? -1 times -1.
1.
1. And then 1 squared? 1. So go ahead and plot those points. 1 and 1. And then make your parabola. Okay, let's talk about this new method. It's called the step pattern. Okay, this step pattern, write it off to the side somewhere. Pattern is gonna follow odd numbers: 1, 3, 5, and 7. Okay. If I start at my vertex point, okay, these steps are going from the vertex. So my first one, I'm going over 1, and then that first step is up 1, which that gives us our 1, 1 point that we found, right? Okay, the next step pattern is 3, so I'm going to go over 1, up 3. And that's my next point. Okay, so each time you go over 1, you're adding 2 extra steps up. Does that make sense? So the first time I went over 1, up 1. Now my second step, I'm going over 1, up 3. Okay, what would I do on my next one? Over 1, up 5. And then it'd be the same way on this side, but do I have to follow the step pattern on this side, or what's an easier way? Just mirror it, right? Here's my axis of symmetry here, where my vertex is, so just mirror it. I'm over here, and I'm over here. So you get the same answer, it's just thinking of a step pattern instead of plugging in values. Okay? But still, what's the most important thing to find first? Vertex, so that you can use that step pattern or use your picking points. Okay? Questions so far? I'm going to come to number 2 last. Let's look at number 4. How is number 4 different than number 1? It has that negative in there. What is our picture going to look like? It's going to go down, right? It's going to be opposite, okay? Still, what's the most important thing to find? Vertex. So we have x equals -b over 2a. Do we have a b? No. Then we have 2 times -1. If we have no b, what's our automatic vertex? 0, right? And then if I plug it in, 0, what's our y value to that? 0. So our vertex is at 0, 0. Now let's try using that step pattern. What is the step pattern? 1, 3, 5, and 7. But remember this negative. What's this negative going to make us do? It's going to make us go down instead of go up. Okay, so my first step pattern, I'm going to go to the right first. I'm going to go over 1, down how many? Down 1. Over 1, down 1. From there, where am I going to go? Over 1, down 3. Okay, I can't go any farther, so I'm going to go back to my vertex, and I'm going to do the same thing the other way. Over 1, down 1. Over 1, down 3. Or the other option you could do is mirror it. Okay, and then make your picture. Okay. Okay, looking at number 3, how is that different than our parent function on number 1? It has a leading coefficient, okay? So we have that leading coefficient 2. We're still going to follow the same thing. What do we need to find first? Vertex first. So we have negative b over 2a. Do we have a b? No, so what's our answer automatically going to be? 0. Okay, if I plug in 0, what am I going to get out? 0. So our vertex is still at 0, 0. Now, what would our normal step pattern be? Right, that 1, 3, 5, 7. Okay. Do you think the leading coefficient is going to change that?
Probably.
It will, right? What I want to do is I want to go back to plugging in points real quick. So let's plug in negative 1 and 1. So what's negative 1 squared? 1. And then 1 times 2? 2. And then what do we know positive 1 is going to give us? 2. Okay. So normally we would go over 1. So I'm going to use that step pattern now. Normally we would go over 1, up 1. So does it work? And then if I went over 1, up 3, does it work? No, but how does the step pattern change?
By 2.
Oh, why did I do that? Did you guys catch what I did? I put them in the wrong spot. But still, did it work? No. Okay? So usually over 1, up 1, over 1, up 3. How many are we going up that first time now? We go over 1, up 2. So what you're going to do with these is you're going to multiply all these by 2. You're going to multiply all your steps by 2. So if we do 1 times 2, we get 2. 3 times 2, 6. 5 times 2, 10. 7 times 2, 14. So you're going to follow those steps now. So if I go over 1, how many do I go up? Up 2. Over 1, up 6. So if you have a leading coefficient, that changes your step pattern. Okay? The reason I multiplied by 2 is because our leading coefficient was 2. Okay? And then mirror your opposite sides. And then draw your picture. So if you have a leading coefficient, you have to apply that leading coefficient to your step pattern, to each step. Okay, and to check if you did the step pattern correctly, you can just use your XY table and plug in points to check. 2. I know I went a little backwards, but why do you think I did number 2 last? Because it has a fraction. Nobody likes fractions. I don't like fractions. Okay? But start with the most important thing. Vertex always. Okay, so find your vertex. What do you notice we don't have? Don't have a b, so it's automatically 0. If I plug in 0, what do I get? 0. So our vertex is at the origin. Now I want to plug in values just to see. So what are values I can pick? -1 and 1. -1 squared is 1 times 1/4. 1/4. And then what's 1 going to give us? 1/4. So go ahead and go plot those. So is our step pattern kind of ruined?
Yeah.
Yes. So start with the original step pattern. What is it? 1, 3, 5, and 7. On number 3, what was our leading coefficient? 2. So what did we do with all of our steps? Multiplied by 2. This time we have our leading coefficient as 1/4. So what do you think we're going to do to each step? Multiply by what? 1/4. Yep, or you can think I'm going to divide by 4. Okay, so if I multiply or all of these by 1/4 or think divide by 4, what's my first step going to be? My first step is going to be 1/4, right? Second step? 3/4. Third step? 5/4. Next step? 7/4. Does everyone understand how I got those? Or do you want me to go through that? We're okay? Okay, so let's use those steps to get some other points. So I went over 1, up 1/4, over 1, up 3/4. Where am I going to be at on that one? I'm going to be at 1. Yep, that's all the further you need to go. Yep, I got 3 points. That's enough. And then go ahead and mirror it on the other side. And then draw your picture.